Hey everybody, welcome to wasmCloud Wednesday for Wednesday, February the 12th. We I don't really have a big preamble. We got a pretty good agenda for today. Um, let's go ahead and get started. I'm just going to share and here. Sorry. Okay, so I know that I am going to kind of leapfrog the agenda here. I kind of mislabeled things as I was coming in. So we are going to get right into some discussion, which should be fun. The first thing is proposing JSON schema for cloud events and structs. And this came up as a couple, one of the things that is on our Wasm Cloud roadmap that we identified as a gap in what we have today. There are two, maybe three issues that relate to standardizing some of our field names and correcting some inconsistencies with the way that we specify host IDs, for example. But the big problem is that we don't have our cloud events and our protocols for Wasm Cloud specified in a way that's usable outside of the Wasm Cloud project. So there's different layers here. But the first one is that our cloud events, which is meant to be something that anybody can subscribe on a NATS topic to essentially have this observability layer into the Wasm Cloud system, the same way that Wadum does to actually run the whole scheduling and orchestration bit of Wasm Cloud. You should be able to just subscribe to this message bus and get all of the events. And then, if you wanted to take actions, do auto scaling, things like that, you are welcome to. Our cloud events are currently defined in the Wasm Cloud Rust codebase and essentially as these like JSON objects. So this these structures for what the cloud events should be like are documented on our website, right? Like in the documentation, you can look up events and go to a component scaled and see a whole example response, like example cloud event for what this would look like. Great. So, if you're hacking something out or writing a script, you can synthesize this and deal with this fine. There are still, the main problem is like that's a chore. If you were working in some other language, you'd have to define this JSON yourself. But this is also a problem because if we make a change to some event, maybe add a new field or deprecate an old field or add a new event, we also then need to go update the documentation. This can be something that's really easily forgotten, especially, we have an open source contributor that adds a new field to the event. We all say it's great, and then all of a sudden our documentation is out of date. This is a problem. So the feature request here was to define specifically the cloud events in some kind of language agnostic IDL, something that can be code gen, something that we can keep up to date and auto generate documentation for, things like that. And I did a little bit of an investigation here. We, of course, have options. First, at the top of the list, we can think of WIT as this language agnostic IDL where we can define structures. There are records, enums, optional fields. There are actually things that you can express in WIT that you can't express in cloud events, like resources, streams. Those things, of course, don't really make sense in the context of a cloud event, so we would just ignore them. But there's WIT, and you can WIT bind gen those interfaces. So, or sorry, the language specific code. So we could do that. Um, of course, we would use it outside of the WebAssembly context primarily, but it would help if you ever wanted to, say, create a component that handled all the lattice events. There's also protobuf, which is a really well-known IDL, and kind of extends into the world of like using gRPC to publish and subscribe and create services. Of course, we right now send these things over NATS, and they're encoded just using JSON as a cloud event, so we wouldn't be like using protobuf encoding for this. I did some experimentation with this, and it actually looked pretty nice. Like it is really not hard to define services and things with in dot protos. You can code gen structures for Rust really easily. There's not as much of support. There's no support for generating services that publish over NATS, for example, but we wouldn't need that. And at the end of the day, after doing some thinking and talking with a couple other people on the wasmCloud side, what I wanted to propose is that we not commit to an IDL in order to do this. And I think what I would like to propose instead is something very similar to what we do in Wadum, which is we have our structures which are written in Rust. So like the Wadum manifest format is just a Rust struct that we deserialize from YAML. And what we do anytime we build release Wadum, we actually use these nice Rust derives to convert that Rust struct into a JSON schema. Then that JSON schema, for example, you can see that this is the manifest. It has API version, kind, metadata, spec. You can take a look at this JSON schema. You can see the title is the name of the struct, the comment that we had in the code, the required fields. So this all works out really nicely. And JSON schema ultimately plays really, really well with cloud events, just the general structure of um, just the general structure of the cloud event payload. So what I wanted to propose, and this is totally up for discussion, no decision has been made here, but I specifically think that making a switch to something like protobuf would add a lot of friction for not a lot of benefit. Like you would need Protalk installed to build wasmCloud. Not a huge deal. I'm sure a lot of people have that. But I think I would either rather define these events in WIT and then code generate them and then work with just those regular Rust structures, which would be good, just a little bit of effort. Um, and what I think this would be the lowest amount of effort for, all of the gain of auto-generating documentation and kind of syncing this across the language boundary, just generating JSON schemas for our events, for our structures, and then other languages can do the code gen from that. You can match the structure against the JSON schema to make sure it's valid, things like that. So yeah, lots of talk, lots of little investigation, but I truly think that this is probably the lowest effort way for us to get in the motion of keeping this updated automatically. Like I said, it's just automatically done whenever we make a change to the struct itself. So I'm curious if folks have any thoughts here on approaching this issue. This is something that is still in triage because it warrants a little discussion. Let me stop. Yeah, Frank.
I'm just wondering, and can you define mandatory fields? And so I'm just wondering how extensible is this?
Yes, yeah. In JSON schema, you can define mandatory and optional fields. So you also define well, you get the whole thing. You also get the type of the field. So, for example, here are the required fields for a manifest. The API version is a string. I could probably find a better. Here's an example of something that is optional. So you can either specify a shared application component properties or nothing. Can be an array, things like that.
Okay, cool.
Yeah, great question, Frank. I'll say one more thing. Please feel free to raise your hand and ask questions. But one thing that this does for us specifically is it doesn't really require any behavior or code change on the Wasm Cloud side. It is pretty much just an extra output from our release, and we can take that output and basically bring that into our documentation. And I think that would be the ideal pipeline for a lot of these structures just to keep everything up to date. There are probably other ways that we can use this as well, but I'll pause on that. Yes, Masood, great question. Did you want to? Well, I'll just say it, and then Brett just talk if you want to say it. Masood asked, "Isn't the cloud event schema already published? Is this about the data port schema?" And that's exactly right. So the cloud event schema, the whole, actually, this is a good. Uh, hmm. This is a great question. So the cloud event schema is already kind of specified. I'm sure that this is a JSON schema somewhere. I don't actually know where it comes from, but the um, structure of the entire, like the top level JSON payload, where it needs an ID, a type of event, the source or where it came from, the data content type, all of that is already specified. That's the cloud event standard. It is just we would be generating the JSON schema for the inner payload type, the inner data type. So for the component scaled event, we would have a JSON schema for this structure, which would include the host ID, the image reference, once we decide what to call those exactly, the instances, et cetera, et cetera. So actually leading on from that, I'm actually not sure when we get into publishing these, if we would need to publish our events essentially as all with the same outer payload, like we would publish a JSON schema for the whole thing, which would include the cloud events spec. That seems very verbose. I think it would be better if we could just publish it for the data field. That would be my intent, basically. Yeah, go ahead.
Brooks, I'm sure you know, but Cloud Events now has mappings for NATS, which basically converts the Cloud Events types, ROS types, to NATS Cloud Event ROS types. So it takes care of the translation for you about how to encapsulate that message as a NATS message, which should simplify, because I think in wasmCloud today that mapping is done by hand, by code.
Yeah, you're right. We use the Cloud Events library and then publish out like the whole payload on our NATS, like our event subject. Um, this is really interesting. I saw this on the crate, like the Cloud Events crate, and I just kind of thought, oh, okay, great. They have support for publishing NATS, like on NATS. But I will take a look a little bit deeper into this. It seems like there might be some aspect of this where it takes the cloud event fields and puts them on the headers or in the subject, things like that. Does it do? Well, okay, I don't need to read the spec right now, but thank you for bringing that up. I will we'll take a closer look at this. All right, happy to take other questions. If there aren't any other concerns, thoughts, then I think that the next step I could basically show like a demo of using this to create that cloud event structure. Maybe pull that into documentation or sorry, the JSON schema structure. See what it looks like when pulled into documentation, or like an example of using that in a different context. But yeah, I think the next step would just be to do the thing. So I can leave a comment on that issue, pointing back to this community meeting. But I think that this would probably be the simplest way to get this done. So folks are welcome to leave extra comments on there too. All right. We are moving right along. I think what we can do, that was the first discussion for today. I think we can actually go back to the demo now, which just to give you a show on the agenda is workload identity. Sorry, the little typo. Workload identity in wasmCloud. So Jonas, you came on last week and kind of gave us a run through of what you were thinking about for workload identity. And now you're going to show it to us, right?
Yeah, and I would I would love for it to be workflow identity, but we're not quite there yet. Maybe we'll get there. All right, so I'll kind of set the stage. Went through some slides last week to kind of high level set with folks. I'll show you kind of a diagram describing. Oh yeah, this is not gather, is it? Okay. Can you all see the browser window? Okay. Maybe.
Yep. Yeah, you might just want to zoom in on the diagram, but that all looks good.
Okay, is that better?
Yeah, beautiful.
Okay, so workflow identity, and specifically, you know, we as part of the proposal, I'm proposing that wasmCloud adopts SPIFFE specifically as the kind of like the standard. It's something that's becoming quickly becoming adopted across the cloud native ecosystem, but also there are commercial offerings that are starting to pop up around this that are centralizing on SPIFFE as the standard, which is really nice because that means that if you don't want to run the backing infrastructure yourself, you have the option to use a commercial vendor, but there's also a very, very good open source reference implementation called SPIRE that they talk about here. Oh, the docs are much better. But anyway, the point is we're going to be adopting SPIFFE, or I'm proposing we're adopting SPIFFE as the kind of the standard. And then for open source, there's the SPIRE implementation, and then you know, there's down the line there'll be also commercial options for folks who might want to be exploring those. And then most importantly, I'm proposing this as an opt-in, not as a hard requirement. I know that came up last week and we were talking about this. And so this is a feature that you can enable for your deployments, but it's not required for running wasmCloud. So just to illustrate kind of the flow, before I show you the thing in action. So the idea is that this is what this diagram here is essentially representing is the workflow, what it would look like to use workload identity for the purposes of establishing or securing your NATS connection. So when the host comes online, the first thing it would do is essentially reach out. I'm using the reference implementation, the open source reference implementation for the purposes of this, which would be SPIRE. So the first thing it would do is essentially connect out to SPIRE agent to request its own workload identity. The SPIRE agent would then talk to different platform APIs depending on what you're running on. So if it's on bare metal, it would talk to or VM, it would talk to like the local kernel for a bunch of API calls. If you're running in Docker, it would talk to Docker for this, or if you're running in Kubernetes, it would talk to Kubernetes or the kubelet APIs locally to validate that the wasmCloud host that's asking for identity is in fact who it claims to be. Once it verifies that it's able to attest that the workload, the wasmCloud host is who it says it is, it'll reach out to the server component of the SPIRE deployment, which is responsible for issuing what they're calling the SPIFFE identity verified identity documents. So it essentially it creates a cryptographic document that represents the entity in question. And at the same time, it'll also propagate that document out to other components or other SPIRE agents that live in your deployment that can be then for the purpose of being able to validate that this particular document. So, you know, it attests this from 1 to 2, it's attesting its identity, or attesting the workload. 3 to 4, it's talking to the SPIRE server and getting its identity back. Once it gets this identity back, it'll send it down to the wasmCloud host. The wasmCloud host will, at this point, initiate a connection out to NATS, to the NATS server specifically. And then in NATS, there's a concept called auth callout that you may be familiar with. And the idea for auth callout is for you to be able to essentially offload the authentication and authorization from the NATS server to an external component. And this will be there's a whole doc for this that I would highly recommend reading through. It's a pretty cool process. I would definitely highly recommend giving a read, even if you're not using Workload Identity. I think there's lots of interesting use cases for this for both users and machines. So the idea is that once the wasmCloud host has its workload identity issued from Spire, it'll present that to the NATS server, which in turn will call the configured auth callout service on the backend. And the auth callout service will then ask the local Spire agent that it's working with, or a Spire agent that it has access to then validate the credentials, the JWT, the SVID, the SPIFFE identity that it was presented. And assuming that the Spire agent says, yes, this is good, this matches my expectations, or this matches what your expectations, because you basically tell it what you're expecting that to represent. And it is valid and it's in the trust domain that your cluster is in. It'll say, yep, you're good. At that point, the auth callout service will then issue a user credential to represent that workload and send it back to user claim to represent that connection. It'll send it back to the NATS server, and the NATS server will respond back to the host, allowing it to connect, essentially. So this is like the handshake that happens when you first connect to NATS. Normally, you would just go through, the host would just connect to NATS, and if you have an auth callout, it would call the auth callout. You do your logic there, and then return back. But in this case, we first talk to the Spire ecosystem, or the SPIFFE identity, and then present that to NATS. So what does that look like in practice? And I'll answer questions in just a second. Let me just get the demo out. Hopefully I've got everything working now. Let me show you. I'm doing this in Kubernetes because it allows me to run all the components locally easily without a whole lot of hassle. I'm sure we'll include examples of how you can run this in other ways. And the upstream SPIFFE and Spire documentation site has tons of great examples of how you can run this in a quick start. So I'm more or less using their quick start examples and their upstream provided hardened Helm charts to run this. So there's like very little configuration you have to do on your part, but there's lots and lots of opportunity for customization for your specific needs. So just to kind of illustrate, this is
Jonas.
Yes.
We just still see your browser window. I don't know if you get your terminal.
Oh, I'm sorry. Yes. Thank you. Sorry. I forgot that I didn't share my whole screen. That's great call out. Where is my sharing bar? Okay, let me reshare. Okay, you can hopefully see this. Let me bump up this font size a little bit. Okay, so
light mode terminal.
I'm sorry. Hold on. Let me tell my system that I need to be in dark mode. Dark.
No, it's okay. It's fine.
I think it's fine.
It's fine. It's fine.
Is that better?
Oh, that's nice. That's nice. Okay.
I have Ghosty configured to respect my system preferences.
Brooks doesn't like bright lights.
Yeah, sorry for the flashbang. I should have given you a flashbang warning ahead of time, especially when my Excalibur was in dark mode. Okay, so this is just the local client cluster that I provisioned just before this call. What I have deployed here is the Spire, as I mentioned, the upstream Spire Helm charts. There's a couple extra components that you probably don't need deployed by default. I just didn't really mess with the variables deploying it. You can turn these things off. You don't need them, but I have them all. It's like give me everything kind of default deployment. All I did is configure the trust domain for the purpose of this demo. And so now, so what I have running here in this cluster that's pertinent for the demo is I have a single node NATS deployment. Obviously, we recommend you have more, 3 or more replicas for quorum. But for the purposes of this demo, I'm just running a single NATS server. It's a stock NATS server. It's configured with centralized auth, and I can talk about that if people want to talk about it for the purpose of auth callout. But what that means is that I have another pod deployed in this cluster that implements the auth callout protocol. And it's more or less based on the upstream. They have some examples, applications that you can take off the shelf and customize just a little bit to make it working. That part is not very interesting, so I haven't done a whole lot of customization. All I added for this is the logic to basically verify the incoming token, the SPIFFE identity token, as a valid token. So that's like the exact customization I had to do there. And what I've also done then on the backside is I have added support in the wasmCloud host code, and I'm happy to talk through that a little bit if people are interested, but I've added support for the wasmCloud host to request that identity from the local SPIRE agent, and then supply that as part of the connection parameters to NATS. So what I'll show you here is when I do, so I have this deployment directory where I just have the different components that are easy to deploy via a tool called Customize. Again, this is Kubernetes specific details, don't really matter. But when I run this command, what it'll do is it'll essentially bring up a single instance of wasmCloud host that is configured to use an experimental feature called Workload Identity. And what that will do is essentially initiate the process, initiate the workflow that I described in the Excalibur draw earlier in the diagram. So let me kick that off. There's a little bit more work to do here in terms of when it first comes online. What happens? It'll crash a few times because it's the in the background, the SPIRE ecosystem has a component that will automatically create identities for pods when they are brought online. That's an optional thing you can do. You can either pre-create these identities or you can have this automated piece create them for you. I have it on here for the purposes of convenience. You'd probably, in a more production grade deployment, you'd probably have some more controls around that. But what happens is what it does is it basically creates the identity when the pod is deployed or when the deployment comes online. And what happens in this case, it'll fail a couple of times because it takes a while for the system to propagate that identity through the system. So hopefully I've stalled enough. So now what you see here is the actual wasmCloud host coming online. And so what the logging I added for the purpose of this is there's a method called connect NATS, which is responsible for handling the connection. I'm just showing you that there's no JWT or key configured for the host to connect to NATS securely, but it does have the workload identity equals true flag passed in because I've enabled the workload identity feature for this host. And so now you can see that the host is just up and running, serving traffic. Now, if I look at the auth callout side of things, this is the custom piece of auth callout code that I've written for the purposes of this demo. Mostly what I'm doing with this is just logging the incoming request to see, to basically see what's going on. And so you'll see that there's an auth token here. And so what this token represents is the actual SVID that is provided by the SPIFFE or the SPIRE ecosystem. And I'll show you that in JWT.io just in a second. And then I also have, actually, I shouldn't show you the NATS logs because they're not that interesting. However, what I'll show you is if we now do, so I have a port forward to the NATS server. Now, if I call the NATS server to report its connections, I apologize, that looks terrible in this font size. You'll note that there's two connections to this host account. And so what I didn't actually mention is, so what I've set up in this NATS deployment is I have an account for hosts where all the wasmCloud hosts live. There's an account for the system, and then there's an account for the auth connection side of things. And so that's actually what you're seeing here is this is the auth callout service. I should have given it a name so that it would register here. But you'll see that there's two connections here to the host account. And you might be wondering why there's two connections. Well, the reason there's two connections is that when the wasmCloud host connects, it actually has a separate connection for RPC and a separate connection for control or CTL. And so in this case, we're using workload identity for establishing both of those connections. We have some flexibility there if we wanted to customize that behavior. But the control connection, and this is where Brooks, feel free to jump in and correct me where I'm wrong. The control command is the control connection is basically used for the purposes of when the host is told to run stuff, or when there's like commands for the host to run. As far as the RPC connection goes, that's actually the connection that the host hands down to the providers that it starts and it's supervising. So this is like the separation between the two connections. Now, to prove the unfortunate thing is I really wanted this to actually show you the identity. Unfortunately, I couldn't quite figure out if that's a bug in the NATS Rust library or if I'm just holding it wrong, which is entirely possible. But I'll prove to you that this is actually the connection using the workload ID. So what you see here is the authorized user. And so if you've never seen SPIFFE before, SPIFFE describes, the way they describe the SPIFFE identity is in this format where it starts with the SPIFFE : / like the scheme. And then it establishes the trust domain. So here I've set the trust domain to be wasmCloud.dev. Usually this could be something like, let's say, useast.production.acme.com, right? And then you get to control this, the path part to basically describe the workload you have in any which way you want. It's the sort of the path identifier. So in this case, I'm using I'm allowing the agent to automatically assign the platform specific implementation. So in this case, what you're seeing is NS, which stands for namespace, default, which is the default namespace that this workload is running in. And I've given it a custom service account, in this case, wasmCloud, to use. And so you're seeing basically that identifier here. So that it basically identifies this as the wasmCloud host using a wasmCloud service account inside of this Kubernetes cluster. And then you see this is the other connection. Actually, I don't have a way to differentiate between the control. So I don't know which one of these is control. Actually, I could tell from the timestamps. So this is actually the client ID. So this is the control connection because it's client ID 45 because the control connection happens before, and then the RPC connection happens right after. And so that's why you see the client ID 46 versus 45. So they're using currently the same identity for workload in both cases. We have some room to decide and make changes here where they could be two separate ones. We also could let the host themselves providers themselves establish their own connections rather than handing them one down. There's a lot of opportunity here what we can do, but the point is what you're seeing here is a SPIFFE identifier which belongs to the host that is connected. And as I showed you before, the host is happily connected, now able to serve workloads. So sorry about that. That's a lot of words. Any questions? If we have time for questions.
Yeah, so it looks like you showed the happy path. And I'm just wondering if you also looked into, especially into the failure modes for all those different components and so forth.
Failure modes in the sense, can you expand on sort of what kind of failure modes you're thinking about? Because I can think of a few.
So, I mean, everything is probably running in, I mean, if you're talking about the kube, they're running in containers. So if a container fails or a connection gets dropped or something, so I'm just wondering, I mean, this becomes a key component on the infrastructure. So making sure that it survives all the failure modes, that will be great. The other thing is actually also versions change from different parts. So what will be the it would be also interesting to think in terms of what's the migration path as things move along.
Yeah, great question. So from a failure mode standpoint, the plan is to have all the components handle retries well, and in a configurable way where you could say, like, if the connection, and I should preface all this that when the plan is to implement this in a way where if your NATS connection fails for the host will retry automatically, and it'll, at the time it retries, it'll request an identity if it can, and if it can't request an identity, it'll retry requesting the identity to a configured number of times. So that way there's sort of multiple levels of retries built in, so that if there's a blip on the network or things like that, it can recover to a degree. Now, if like you're hard down or network connections are split or things like that, it's just not going to work. But I think that's true today, regardless. Like if you can't talk to your NAT server, you can't talk to your NAT server. But the basic, I would say, the first line of defense here is that we'll have retries on every level to make sure that to the point that you configure it to, it will try to retry the connections, both NATS connections, as well as getting its identity before it gives up. And if it can't get its identity, then it should fail closed, meaning that it will not be able to connect to NATS. That's, I think, the desired behavior, because if for whatever reason that host is like partitioned from the deployment, I don't think it should keep running on its own necessarily. Now, if there's a network split, the host it has established a connection. I don't think that'll actually like fail the host itself. The host will happily keep running to a certain point. I don't actually remember what is the interval, how often these things would get checked, but I think it would essentially it would fail to heartbeat is probably when it would start failing. So that is probably the desired behavior.
The TTL on the certificates is configurable, but it's probably longer than the heartbeat. So, and also just like as a general point, as Jonah was saying in the beginning, was that this is a production level system. Like at Adobe, we use this in our FedRAMP clusters and things like that. So SPIRE and SPIFFE are real technologies that are used in enterprise systems.
Yeah. Some examples is like, for example, Uber, I think, has 16 million identities under management from this system that are refreshed I want to say every 5 minutes, but it could be every hour. They have
I mean, I do understand all the retries and so forth, but I was wondering, so when you bring a container back, so you're making sure that this is the right container, that it's running again and so forth, and there's nothing weird happening there. So that's some sort of failure mode that I was also thinking.
Yeah. The whole point of this is that each host will have a cryptographically verifiable identity that proves that it is supposed to be part of that cluster, supposed to belong to that cluster. And when it talks to other services, it can present that identity in a way where it can be validated and verified by different components. So this is this use case that I'm presenting here is the one where we connect to NATS, but you can imagine, for example, using the same identity for the purposes of pulling images from a registry. So this way you could write policies in the registry on the registry side to say these only hosts that belong to this trust domain have this name can pull images, for example. And so what this allows you to do is start writing policies on the receiving end of the token to then validate, like make assumptions about who's talking to you, and it can be verified. Like there's a way to verify this based on the standards, based on this sort of the SPIFFE standard, basically. So,
right. Okay. Thank you.
Yeah, but I'm happy if you have more concerns. I am planning on opening up a GitHub issue describing the initial implementation, and I'd love for you to bring any of those concerns as part of that issue, because I think it's important that we make sure that every concern is addressed in a way, or at least we've made a note of it, and even if we decide to address it later, or if we'll have an answer for everything. We're not trying to reduce your availability. The idea is to basically keep it equal, but also make it more secure.
Right. Thanks.
Yeah. Brooks, go ahead.
Yeah, I was thinking about this. I know that this is kind of there's an opt-in feature, not something that you have to use. If you have some automation already set up, you can still like kind of provide credentials to hosts, and they can be like authenticated against the network and everything. But beyond that, I think it's really interesting that like right now, whenever you start a wasmCloud host, it generates its own identity like that, the NATS in key public key. And it's like, here I am, I'm unique. And it doesn't seem like this changes any of that. And this is probably just reiterating what you just said a few minutes ago, but just to drive it home. So the whole point of this demo, like this work, is it that now we know that host's identity, its connection, is like verifiably should belong to this NATS cluster, and it's using that like existing standard to do so that we can kind of build on those tools. Is that right? I want to make sure I understand it correctly.
Yes, that's exactly right. Yes. And I think to that point, we could have kind of sort of done that before, but this will actually not require any secrets. Like this is a secretless approach. in that it reuses the existing primitives from the platforms you're already running on to prove that identity. And so you don't have to add any secrets. Like you don't have to provide a NATS credential file or a TLS certificate or any of those things. This will automate that process. The whole point of this is to solve sort of the secret introduction problem and even allow you to alleviate secrets in the case like the OCI, where you can write policies on the other side to decide whether something should be authorized based on the cryptographically verifiable identity that you're presented, right? Because you can validate that thing is real, is actually who they say it is, and then you can, based on that, decide, is this entity allowed to talk to the service that it's trying to talk to. So that's kind of the idea, is like to remove the need to store or present or provide secrets for the host to connect. There's also, I haven't fully explored this, but there's also the possibility that we could use. So I was showing the JWT based token based approach, but there's also a way to request an X509 certificate, which also represents the entity, like the cryptographically verifiable identity. So there's the opportunity to potentially use that for establishing a TLS connection to the NATS server. Right, so we could basically kill two birds with one stone, secure the connection to NATS server, and use that same strategy to basically establish the identity of the client that's connecting in, which would be nice. I haven't fully explored that because I think that messing with TLS can sometimes be a little bit like extra for people. So I've kind of gone with the path of least resistance using the tokens, because that's kind of the path we employ today for the most part with the credits files and things like that. But there's also future opportunity for like additional improvements, such as automating the mutual TLS connectivity between the two.
I just had a super quick follow-on. So like if I'm a platform person, I'm deploying this, I'm enabling the workload identity bit, where do I actually add the decision logic? Like, is it in the NATS auth callout where I decide if it should get it, or is it like configuration to the SPIFFE server, SPIRE? So, yeah,
Great question. So the auth callout, for the purpose of what I demoed, the auth callout service implementation is responsible for deciding whether a given host is allowed to connect or not. And the NAT server will present all of the connection information that it received as part of getting the connection from the host or from the connecting entity. So you will have essentially you have the same JWT on your side, and you can decide you can make decisions then on with that. And so my plan is to provide like a reference implementation that once I clean up the code that I have a little bit, because it's just using the kind of it's not in a very pretty format, and there's some new tooling that we should just use from the NATS folks to like make it really concise. But the idea is to basically provide a reference implementation as part of the initial like spike, or the initial like experimental feature is to give everybody be able to basically run this demo locally yourself, and then make it yours. Go ahead, Liam.
So to wrap this all up, if we wanted to have a complete end-to-end story here, if we were starting wasmCloud nodes, or if wasmCloud had like some sort of T integration, it could boot on a piece of hardware and check to see that it's downloading a signed wasmCloud host process, and then that would be enough to sort of bootstrap this thing from random hardware all the way back to secure end-to-end identity then, right? That's
Yes.
amazing.
So Bloomberg actually has a TPM-based workload attestation, or sorry, I think it's a node attestation piece that allows you to basically know that that node is allowed to be part of the cluster. So yes, you can also integrate it into things like cryptographic identity from your underlying hardware, for example, that you might be running on, or you could bake these things into, like if you're shipping hardware, you could bake something into hardware itself that was part of the process. Just one quick note I'll say, one of the things that makes this the SPIRE ecosystem really appealing that I didn't really talk about, but it is extremely pluggable. Like they have done a really incredible job of exposing a lot of the surface that's necessary for the different parts of this for establishing the whole process end to end, which makes it so that if you want to customize it for your needs for a specific deployment, you have a lot of ways, like writing a custom plugin, they're not a lot of code. They're super simple to write. And there's plenty of great examples in the built-ins, but also in the broader community. Like I mentioned, there's a TPM from Bloomberg, and there's a couple other ones that I came across as I was looking at this. So there's a ton of flexibility from an integration standpoint to existing systems that might be proprietary to your company or that like just don't make sense in the open source. And you can like really use it to customize the deployment. So you're not stuck with what they give you out of the box, even though what they give you out of the box like covers probably 95% of the deployments out there, if not more. But there's always like they have the escape hatch of having a ton of different plugin surface to be able to plug in the appropriate places at the appropriate layer. So really that I think is one of the key benefits of why I think really confident about Spire moving forward with the Spire.
That's awesome. We have had a number of people to chat with us about a TPM implementation or TPM support for wasmCloud so that you could boot from an Intel architecture anyway into their TPM set. And I think, Apple has always had their secure enclaves on their hardware. And I think ARM has a general project here, like secure something enclaves that I think is a very similar idea here to get there. But that would be an interesting thought exercise to spin some cycles on. Thank you, Jonas. Appreciate it. Awesome work, by the way. I can't wait for this to land.
Yeah, awesome. Well, hey, nice. I'll take that. I won't say your timeline on the call unless you want to say it, but looking forward to seeing the PR.
Yeah, I'll just say it out loud. I have an initial draft PR that I would like to land in upstream today. I also have an issue, like an RFC describing the flow at a little bit higher level that I want to open up. So the draft PR kind of like implements what I'm describing in the RFC as a way to open up the conversation, and then we can build on it. It's certainly not going to be the end-to-end story. There's still lots of other places we will want to integrate, but we have to establish the foundation first at the host level in order for the other layers to make sense and for them to come in. So that's why it's like we're starting with the host because that's the foundation for everything else. But then we can rapidly expand once that foundation is in place. We can add it to other places. I think Colin had a comment before.
It's okay.
Alrighty. Well, got one. Thank you, Jonas, again. Awesome demo, awesome questions and conversation. Well, got one more thing to talk about today, which has been kind of fun to look into. So I guess that you can call this like the tiniest little demo. I guess I'm not all doing it live, so it's not a demo, it's a discussion, whatever. But I did want to talk a little bit about something else that we have on the roadmap, which is I zoomed all the way in for dramatic effect, but I will find it first. More around using, no, not that. Conventional commits for release notes and change logs. And there are tons of conventional commit tools that can generate change logs for releases and things like that. But I started looking into some of this, and I want to show you the end result, and then we'll kind of talk backwards from there. So I open a PR into wasmCloud where, I wrote this super cool new feature. It's a breaking change and it's related to wasmCloud. So I write my conventional commit, which has the type feature, the scope wasmCloud, and then this little exclamation point in the commit message, which means, hey, this is a breaking change, API, command line flag change, public member change, whatever. Needs to be a minor version bump at least. And what we have almost now is when you do this, we have a little script in a GitHub action that can read this commit message and automatically add labels to the pull request regarding the type, the scope, and whether or not it's a breaking change. So all of that now is all I zoomed in for, so it'd be below the fold. All of that essentially culminates in this PR, which thank you so much to Lachlan and Roman for working with me on this. There was a ton of considerations and changes here. But essentially, in the action after we validate that a commit is a conventional commit, so that is in this first part, we use the convco CLI, it's somewhere in here, to validate that it's a conventional commit. And then afterwards, what we do is we look at all of the commits in the PR, and then we scan them essentially for the whether the impact is breaking, the type is a fix, type is a feature, CI, things like that. The cool thing about this is it's not just something that we are keeping track of so that we can, bird's eye view see what a PR is about. We can actually use this in the GitHub automatic changelog generation feature. So not needing to adopt an additional tool to change the way that the release notes are formatted. So we have a couple of options like excluding authors, including certain labels, excluding certain labels. Here's an example, release.yaml. But what this ends up doing is two things. One, we can ignore Dependabot from being in our release notes, which is great. Sorry, Dependabot, we love you. You're the #1 contributor to wasmCloud now. But we don't want like the chore version deps bumps to be a big part of our commit message. We can also essentially nest the breaking changes, the new features, the fixes under their own markdown headers. So we can essentially automatically organize our release notes. So you can see, oh yeah, I was looking at that. You can see and I actually did a little bit of this now in our wasmCloud repository. We have a release.yaml that just excludes Dependabot. But once we land this and we start labeling all of the PRs automatically, you can see in our recently generated like wasmCloud 1.6.1, I didn't have to modify this at all, but it excluded the Dependabot commit messages from this. So really, this is all just to say that I think we found a really nice balance here of being able to use conventional commits the way that we do for our repository. We enforce these on every commit, by the way, and like on the maintainer side, if we need to, we'll kind of reformat it to be a conventional commit. But now when new PRs come in, this little bot will automatically label it bot LOL. It's a bash script. We'll label it for the scope and whether it's a breaking change. And in addition to kind of nice change logs and kind of bookkeeping, this addresses a big concern that we had around making sure that we're surfacing breaking changes, especially in the provider SDK for provider developers, especially in the libraries that other people could use in other places, not just for wasmCloud. So I think this is going to be a huge help for that, and I think we'll see it in our first like provider SDK release after we actually land the whole actions bit here. So happy to talk about how this all kind of went together. It's landing right now. The PR that I showed you is like finalizing the action, and we probably need a little bit more testing. But this should be a huge help, especially for folks who are on the maintainer side doing reviews and kind of want to make the well, like I said, we get to use all of the same GitHub tools that we've been using for generating change logs. We just get to use this extra little YAML file, and it makes everything nice and formatted and better. Do folks have any questions on that one? Change logs. Yay. All right. Well, I know that we are at the end of the call, and I apologize for going a little bit over. If anybody needs to go, please feel free. There is one more thing that I promised we would talk about today, and I'll just make it really quick. Ahmed, who is a Wasm maintainer in the wasmCloud community call right now, has taken on a fairly large chunk of work to combine the Wash library and the Wash CLI into a single crate. And as we saw just over the past week, this is going to get really, really difficult to manage the more changes that we make to the library in the interim. So what I'd like to propose is that we release Wash 0.39. Like that is the latest version. That's basically, I know it hasn't been long since the last version of CLI came out, but versions are free. We release that version of the CLI, and then any changes that we need to make to release fixes or new features, I propose we do in a feature branch. So basically freezing the action, freezing code changes for wash on main. And this will essentially give Ahmed some breathing room to finish the migration. And then we can essentially do one more version bump where we deprecate the old crates and then start publishing just to wash. This is mostly a socialization thing. I don't think anyone would have like what's the word? Take offense to that. Please let me know if you are working on something that you need to get into wash right away. But unless there are dissenting opinions, I would propose that we just hold off on emerging, especially new features or bigger changes to wash for the next week, and then hopefully get to releasing the new project and making changes there by next week's community call. So yeah, please reach out since we're into the call. I mean, raise your hand now if you have if you don't like that. But I think we should just rip off the band-aid, get it done, and then we'll be able to look back and laugh at all of this. Folks have any questions? Anything they wanted to add there?
I'll just say that as part of the work that I demoed, I learned that when you pass a credentials file, we actually read it only once. But if that file were to change, for example, behind the scenes, we don't ever reread it. So your host will actually fail, and the next time it tries to use those credentials. So what I'd like to do is actually have that be passed in full all the way through. And I think I was waiting for some of the wash work to land to like make that change happen. But yeah, it's amazing. I'm really excited.
So do you just need like when we release the latest version? Well, the washboard can update independently now from wash, right?
Yeah, actually, yes. We don't have to get into the details here, but I'm happy to like offline talk you through what I was thinking
Okay.
about. And I was just waiting for the wash stuff to emerge because it's I didn't want to create more rift.
Sure. Yeah. Okay. Yeah, no, it's great to hear. I just want to double check before we start telling people in PRs like, hey, wait, and then do it somewhere else. Cool. Well, then that is what we will do. Thank you all for coming to the community meeting today and hanging out for a little while. I figure folks have to dash, but thank you so much. Have a great rest of the week.